Hi children, today I'll teach you prime and composite numbers. When we say prime and composite numbers, it should come to our mind that we need to work on positive integers. We learned what a positive integer means in our previous lessons. Now let's come to the definition of prime and composite numbers. Numbers that can only be divided by 1 and itself are called prime numbers. So 5 is a prime number. You can easily tell me that 5 is a prime number because 5 is divisible by only 1 and itself. There is no other divisor of 5. What about 6? 6 is not a prime number because, yes, 6 is divisible by 1 and itself, but 6 is also divisible by 2 and 3. Because of this fact, 6 is not a prime number. Now let's continue to the definition. And all positive integers other than prime numbers like 6 are called composite numbers. Now let's write on our desk this definition. This is our definition that I explained to you, and continue to speak on this subject. Shortly, composite numbers are numbers formed by multiplying prime numbers. For example, 6. 6 is equal to 2 times 3. 2 and 3 are prime numbers, and their multiplication gives us a new number, 6. So 6 is a composite number with this definition. In this case, if we are talking about composite numbers, we need to find out by which prime numbers create these numbers. Let's write on the desk again. Very important. Very important, this subject. If we are talking about composite numbers, we need to find out by which prime numbers create these numbers. Let's continue. In this case, we can compare prime numbers to cells, which are the building blocks of our body and our organs. Am I right? Which are formed by the combination of cells to composite numbers. So the cells in biology like prime numbers. The organs, our body, are like composite numbers. Our body and our organs are made up of these cells. So composite numbers are made up of prime numbers by multiplying them. Now let's write this fact on the desk again. Let's continue with the next page and continue to explain the meaning of prime and composite numbers. The process of finding out which prime numbers are composed of composite numbers is called prime factorization. This is another definition, and the subject prime factorization is very important for us. In all mathematics, we'll need this subject, so we should concentrate on the definition of prime factorization. On our next lessons, we'll find all composite numbers prime factorization. This is our unforgettable definition of prime factorization. Now let's continue again. In order to learn the subject very well, we'll first focus on prime numbers. Now, if you wish, let's work on the method of which numbers from 1 to 100 are prime numbers. Now let's continue with this subject. Concentrate on to find all prime numbers from 1 to 100. And what I have numbers here on a desk from 1 to 100, all numbers, and I should find the prime numbers from 1 to 100. Of course, by which method? Which method? The method is to skip out here all numbers which are not prime. Namely, I'll skip out all composite numbers. I'll clean from the desk all composite numbers. Before this, let's speak on a composite number. I told you before 6 is a composite number because 6 may be written as 1 times 6. It means 1 and 6 divides 6. But other than this, 2 times 3 is also 6. It means 2 and 3 are divisors of 6 other than 1 and 6. This is the reason of being composite number. If 6 is written as the multiplication of 1 and itself, then it's a composite number. Yes, it's true. It may be written as the multiplication of 2 and 3. So 6 is not prime, it means 6 is composite. Now, I'll find all composite number. As you see in the example here, a composite number is the multiplication of prime numbers. So, if I start from the least or from the smallest prime number, what can I tell you? 2 is the smallest prime number. What about 1? 1 is neither prime nor composite. So let's clean 1 from the desk firstly. Neither prime nor composite. So let's come to 2. 2 is a prime number, the smallest prime number. So all multiples of 2 other than 2 are composite numbers. Cannot be prime numbered, I mean. So I should clean all multiples of 2 other than 2 from the desk. It means I should clean all even numbers except 2 from the desk. If a number is divisible by 2 or the multiple of 2, it's even, you know. So let's clean all even numbers. This column is all even, this also. So my job is very easy, I think, after cleaning all these even numbers from the desk. They are composite numbers. Clean this column and this also. So after 2, 3 is the second smallest number after 2, of course, prime number. So all multiples of 3 are composite numbers. So I should clean from the desk multiples of 3. 3 it's prime, so after that 6, after that 9, I cleaned before 6 because even, you know, after that 12, after that 15, 18, 21, 24, 27, I'm going 3 by 3, as you see, 27, after that 30, 33, 36, 39, 42, 45, 48. Because of being even, it's claimed before, because 48 is at the multiple of 2 or even number. After that, 51 claim, 54, 57, 60, 60 as you see claimed before, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, 99. And so I claimed all odd multiples of 3. What about the even multiples of 3? It claimed they were claimed before because of being the multiples of 2. So after 3, 5 comes as a prime number. So I should claim all multiples of 5. 5, 10, 15, 20, and 25. Let's claim it. 30, 35, claim. 40, 45, 50, 55, 60 claimed, 65, 70 claimed before, 75 claimed before, 80 claimed before, 85, 85 is here, claimed, 90 claimed before, 95 claimed, and 100 claimed before. So let's go with 7. 7 is a prime number. 7, let's concentrate on the multiples of 7. 7 is prime, don't claim. 14, 21, 28, 35, 42, and 49. 49. Let's go 7 by 7. 56, 63, 70, 77. Yeah, 77 is also should be claimed from the blackboard. And 84, 91, yes, should be claimed from the board. And 98 claimed before. So that's all. What about 11? 11, 22, 33, all claimed before. 44, 55 claimed before. 66, 77 claimed before. 88 claimed before. 99 claimed before. So there is no other number, other multiples claimed from the blackboard can be claimed from the blackboard. What about 13? Now let's think about it. If there is no multiples of 11 where we should claim from the desk, so for 13 the same thing can be told. What about 13? Because of skipping out from the desk all multiples of 2, 3, 5, 7, and 11, after that I should claim 13 times 13 at least. If I multiply 13 with 11 or 7 or 5 or 3 or 2, I will reach all multiples of 11, 7, 5, 3, and 2, and that where I claimed before. So if you multiply 13 with 13, you will get a number, of course, which is not prime, namely composite. You will reach a number greater than 100. So our operation has just finished. I reached all prime numbers on the desk. I colored green before all prime numbers for you. As you see, can you find another number on the desk not claimed before other than green areas? No. So all numbers colored with green are prime numbers from 1 to 100. I think you understood how you may find all prime numbers from 1 to 100, and you may find all other prime numbers from 1 to 2000 or 200s by the same method, but it will take time. Now, according to this way, I should explain you something. Let's come to in a free place and let's try to find whether a given number to you prime or not, prime or composite. For example, 300s 83. Is it prime or composite? How you may understand. Now I should find the square of all prime numbers from the least one. I should start. Let's return to our last subject here. As you see, I explained something here. If you multiply 13 with 13 again, you will get a composite number, which is not prime, but it exceeds 100. So I stopped here, and so it means 2 square is not greater than 383. So 2 should be considered for 383. If 383 is divisible by 2, it means it's not a prime. So let's continue with 3. 3 square is 9. 9 is less than again 383. So 5 square is 25. Is okay. 5 is okay. So because 5 square is 25 and 25 is less than given number. And 7 square is 49. Yes, okay, 49 is also less than the given number. What about 11? 11 square is 121. So again, I may consider 11. What about 13? 13 square is 169. 169 is again less than 383. What about 17? 17 after 13, 17 comes as a prime number. 17 square is 289, and again this number, it means 17 square is less than 383. It means 17 also should be checked. And what about 19? 19 is also a prime number. Its square is 361. But after that 23 comes. 23 square is greater than 383. Because of this fact, I should stop at 19. So I should check that 383 is divisible by these numbers or not. I should check this fact. Now 383 is not divisible by 2 because it's odd number. What about 3? The summation of digits of 383 should be divisible by 3 if this number is divisible by 3. 3 plus 8 is 11. 11 plus 3 is 14. 14 is not divisible by 3. So 383 is not divisible by 3. What about 5? It's not divisible by 5 because the unit digit of this number is not 0 or 5. What about 7? Let's check it here. If it's divisible by 7, then it's not prime. It's composite number. 5 times 7 is 35. Yes, it's not divisible by 7. What about 11? It's not. Let's check it. 3 times 11, 33. 5 and 3, 53 is not divisible by 11, so it's not divisible by 11. What about 13? What about 13? Let's try to divide here with 13. 26, 2 and 1. What about 123? Is it divisible by 13? No, so 13. And what about 17? 17. Let's divide here with 17. 2 times 17 is 34. And 43 is not divisible by 17. What about 19? The last one. If this number is not divisible by 19, then 383 is not divisible by all these numbers, and it's prime. 38, 0, 3, 0. It's not divisible by 19. 383 is not divisible by all these prime numbers from 2 to 19. It means 383 is a prime number. Right here the result. It's prime. Did you understand the fact? Now let's give another example which is prime, not prime, which is not prime. For example, 91. Is it prime or not? 2 should be checked. 3 should be checked because you are taking their squares. If their squares are less than 91, then we should check whether they divide 91. 5 square is 25. Okay. 7 square is 94. And 11 square is 121. So it's not divisible by. We should not concentrate on 11. Sorry. We should not concentrate on 11. Now, if one of these numbers, 2, 3, 5, and 7, divides 91, then 91 is not a prime number. It's composite. 91 is not divisible by 2. What about 3? 91 is not divisible by 3. What about 5? Not divisible by 5. Now let's come to 7. If 91 is divisible by 7, then it's not prime. It means composite. In 9 we have only 1 7. 1 times 7 is 7. 2 and 1. Oh, that. 21. In 21 I have 3 7. 3 times 7 is 21. It means 91 is 7 times 13. So I got a result. 91 is divisible by 7. It means 91 is not prime. It means 91 is a composite number. 91 is divisible by 1 and 91 itself. But other than these divisors, 7 and 13 are also the divisors of 91. So 91 is not a prime number. Now children, I stopped here. I'll stop here. Now we reached a very beneficial result in today's lesson. We learned the meaning of prime number, and we learned how we may find whether a number is prime or not. And we learned a method to understand it. We learned how we may find all prime numbers from 1 to 100. And we'll continue this important subject on the next lesson. See you soon. Bye.